Assalamu alaikum warahmatullahi wabarakatuh. Welcome to Wisdom International School's digital classroom for mathematics. So children, we are going to continue with trigonometry. I hope you people have memorized the ratios, trigonometric ratios, and how to solve problems based on that. So I hope you have completed exercise, the first exercise in your classwork. Now let's move on to introduction to the trigonometric ratios of some specific angles. Okay, so now if I say, see, we already know that sine theta is the 45, sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and so on, right? Now, when it was just an alphabet or theta, you just wrote it as opposite over hypotenuse or whatever. But then this theta is actually an angle, isn't it? So you can have an angle instead of theta, instead of A, B, C, they can tell you what is sine of 30, what is sine of 40, what is sine of 50, and so on, right? So we are going to learn how to find the trigonometric ratios of some specific angles. Okay, we can't solve for all the angles actually, right? I mean, right now at least, there are other ways of solving it, but right now, we'll just learn to find the sine ratios of specific angles. Like, we'll find out how to find the angle for 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. Okay, so for these five, without using the calculator, we'll try to find out. So obviously the calculator is going to give you the answer, like sine of 40 or sine of 50 or something else. Also, if I ask, it will give you the answer, but we need to do it without the help of a calculator, and we can do it for these angles very easily without the help of a calculator. Okay, so first we will learn how to find the trigonometric ratios of 45 degree angle. Okay, so for that we have to learn two special triangles. Okay, two kinds of triangles. Let us say we have this triangle, a triangle which consists of 45 degree, 45 degree, and 90 degree. See, it's a right triangle, so one of the angle is 90 degree. So let's say that the other two angles are supposed to add up and give you 90 degree, right? So let us say that those two are equal angles, like 45, 45. Okay, so 45 plus 45 gives you 90, right? So this, if the angles are equal, the opposite sides are equal, right? Because it's like the angles are equal, the opposite sides are equal, so it turns out to be an isosceles right triangle. Okay, so let me say the opposite sides are some A and A. Then what happens to the hypotenuse AC? I'll have to solve using Pythagorean theorem. AC square equals AB square plus BC square. So you get A square plus A square. See, this is how you solve it. Okay, AC is equals to square root of 2A square, and A square, it's A square, so A comes out, root 2 remains inside, so you get A root 2. Okay, so if I give you a triangle where I say this is 3 and this is 3, this is going to be 3 root 2. If I give you a triangle where this is 5 and this is 5, this is going to be 5 root 2. Okay, if I give you a triangle with this is 1 and this is 1, this is going to be just 1 root 2 or simply root 2. Okay, so you should understand this. Okay, you don't have to actually sit and solve all these things. Okay, you can just remember this. Okay, so now if I ask you what is sine 45, so you can take any 45 because both of them are 45, right? So you take it, let's say take with this as the 45. Okay, so for sine 45, you know that it's opposite over hypotenuse. So opposite for this hypotenuse, this 45 is A over A root 2. Now the A gets cancelled and you get 1 over root 2. So this is the answer. Now cos 45 is adjacent over hypotenuse. So again you get A over A root 2, where A gets cancelled and you get 1 over root 2. So for sine for 45 degrees, sine 45 and cos 45 are same. Now let's find out tan 45. Tan 45 is opposite over adjacent. Okay, so opposite is A, adjacent is also A. So A gets cancelled and you get simply 1. Okay, so tan 45, irrespective of what the sides are, tan, like you give a big triangle with 100 and 100, then even then you're going to get the same answer. Okay, so similarly you can find the secant 45, cosecant 45, cotangent 45, all those things. Okay, so you just have to simply use the formula. Now coming to the next one, like the second triangle is 30, 60, 90. Let us say you have a triangle like this. See, there is a way of deriving this also, but that's not required for you people, so I'm not just going to explain how to derive this. Okay, you can just memorize this. See, just draw a triangle. Okay, this is 90, one side is 30, let us say the other side is going to be 60, right? Because it should add up to 90, no? So let's just split it like this. So always take it like this. The side opposite of the smallest angle. See, the smallest among this is 90, 60 and 30, right? The smallest among this is 30. So the side opposite 30 is, let us say, A, or just 1. Okay, let me take just 1. Then the side opposite of 90, which is the largest, will be double of whatever it's here. So it's 2A, or you can say if it is 1, it's going to be 2. Understood? If this was taken to be 4, if A is 4, then this thing over here will be 2 into 4, 8. Okay, so the side opposite opposite 30 will be considered as a single number, and the one opposite the 90 is the double of that, and the one opposite 60 is A root 3. So that you can find it using the Pythagorean theorem. See, here is the calculation. You can just go over this. Okay, just the same Pythagorean theorem which we have been doing again and again. Okay, all right. So you get this thing as the side opposite 60 as A root 3. So if you have a triangle, so you just remember like this: side opposite 30 is A, side opposite 90 is double of A, so 2A. The other one is A root 3. Okay, so if I say that this is, 2, this is 30. Okay, let's say this is 30 and this is 60, and I say that this is 5, then what will this be? This side will be 10, this side will be 5 root 3. Understood? So the 30, if you have one side, from that you can find the other ones. Okay, so now if I give you a side like this, okay, and I say, okay, this is 30, this is 60, and the side opposite 90 is, let us say, 50. So then 90 is 50, so 30 has to be half of that, so it will be 25. So this will be 25 root 3. That's all. Okay, so that's very easy. So now if you want to find what is sine 30, you have to use the 30 degree. Go to 30 degree over here and see opposite over hypotenuse. So opposite is A, hypotenuse is 2A. So A over 2A. So A gets cancelled and you get 1/2. Then come to cos 30. So for cos 30, you have to go for adjacent over hypotenuse. So adjacent is BC and hypotenuse is AC. So A root 3 over 2A. So again A gets cancelled and you get root 3 over 2. So tan 30 is opposite over adjacent. So it's going to be AB over BC. AB is A and BC is A root 3. So A gets cancelled and you get simply 1 over root 3. Okay, so similarly, if I ask you what is sine 60, so you go to the 60 degree angle now. So look at this angle, and now you will see what is sine of 60. So sine of 60 is opposite, which is A root 3. BC is the opposite for sine 60 over hypotenuse, so 2A. So BC over AC, which is A root 3 over 2A. Okay, so if you want, I can draw the triangle over here. Just, see, let's say this is 60, this is 30, and this is 90. This is going to be A. This will be taken as 2A, and this will be taken as A root 3. Okay, so you get opposite over hypotenuse in the first case. So that's going to be A root 3 over 2A. So the A gets cancelled and you get root 3 over 2. Now cos 60 is adjacent over hypotenuse. So go to the 60 degree angle and see the opposite is, the adjacent is A and divided by 2A. So the A gets cancelled and you get 1 by 2. Similarly for tan 60 you get BC over AB, which is A root 3 over A. So you just simply get root 3 over 1, which is root 3. Okay, so similarly you can find for the other 3 also. Alright, so now that's how you will find the angles for this 30, 60 and 45. So we have got these 3 angles, right? Now we are going to learn how to find it for 0 degree and 90 degree. Okay, so let us take a x-axis, y-axis. Okay, let's say, so let us say this is 0 degree. So if I have a triangle, let me take a triangle over here, a point over here. Okay, so this point is x comma y. So this is the ray which is rotating actually. Okay, so if I try to make a triangle out of this, what do I get? This is x and this is y, and the r is hypotenuse. See, r square is equals to x square plus y square. Okay, so you have so this is 0 degree. See, look at this. If I draw the angle on the x-axis itself, the angle between this ray and the 0 degree is and this x-axis is nothing, right? So that's why we call it as 0 degree. Now if I just rotate this, this black line, and it comes to this point, then it's going to be called as 90 degree, because this is the 90 degree. Now if it goes further down, it will be called as 180 degree. This is 180, and further down it's 270 from here to here, and then one complete rotation is 360. Okay, all right. So now we know that if you have a point on the coordinate plane, you can say that this base is x, this is y, and this is r. So now if I ask you what is sine theta, you will say it's opposite over hypotenuse. So opposite for this is y and hypotenuse is r, and cos theta is going to be adjacent over hypotenuse, so that's going to be x over r, and tan theta is opposite over adjacent, which is equals to y over x. Okay, so this is what you are getting. And remember, one more small thing I want to tell you: tan theta could also be written as sine theta over cos theta. Okay, this is another way of writing tan theta. Okay, and cot theta will be cos theta over sine theta. Okay, we'll come to this later on. Now here, when we look at this, so let us say we know this thing, right? See, r square. So you should remember this. Okay, that is sine theta is equals to y over r, cos theta is x over r, and tan theta is y over r, x. Okay, you should remember this. So now if I have a 0 degree and 90 degree, we are not bothered about the 180, 270 and all, just the 0 and 90. So let us say that there is a point over here, and this point has got a point as 1, 0. See, if this lies on the x-axis, so if I will take the simplest number for this, so let me say this particular point is 1. So the point is actually 1, 0, no, because y-axis is 0. So x turns out to be 1 and y turns out to be 0. So sine 0, if I say, is going to be y over r, and r is always 1. We know this. Okay, r is always 1. If x is 1 or y is 1, if one of them is 1, then r is going to be 1. See, this is how you are getting it using the Pythagorean theorem, right? So here you see sine 0 is equals to y over r. I told you we have to remember this, right? So that's going to be y is 0, 0 over r is 1. So 0 over 1 is 0. Cos 0 is x over r, so 1 over 1, which is 1 again. Tan 0 is y over x, so that's going to be 0 over 1, which is 0 again. Now, cosecant is reciprocal of sine, so or r over y, that's 1 over 0. See, if you have 0 in the denominator, you will write not defined. Okay, so it's not defined. Now, secant 0 is r over x, so 1 over 1, which is 1. Cot 0 is again 1 over 0, which is not defined. Okay, now when it comes to 90 degrees, so let us take a point over here. This point lies on the y-axis. Let me take this point also as 1. So then this point will have a coordinate of 0, 1. So your x turns out to be 0 and y turns out to be 1. So when x is 0, y is 1, again r is going to turn out to be 1. Okay, so now sine 90 is y over r, so 1 over 1, which is 1. Cos 90 is x over r, so 0 over 1, which is 0. And tan 90 is y over x, which is 1 over 0, which is not defined. Okay, similarly cosecant 90 is r over y, so it's 1. Secant 90 turns out to be r over x, so 1 over 0, which is not defined. And cot 90 is x over y, which is 0 over 1, which is 0. Okay, so what all we have done, I have explained so far. You can, if you understand it, you don't have to memorize them. All right, but then if you are finding this difficult, you can just memorize this table. So you see this table being given. So you can use this table to memorize this. This table gives you everything about your 0 degree, your 30 degree, your 45 degree, everything, right? 45, 60, and then you have 90 also for all the things, like all the 6 ratios. See, if you look at it, you have sine A, cos A, tan A, and you have cosecant A and secant A and cot A also, right? So how do you learn, how do you read this graph actually? How do you read this table? So here you come to your, so if you want to find out sine of 0 degree, okay, so you go to this sine of 0 degree over here. Okay, sine of 0 degree is 0. Okay, if I want to find what is cos of 30 degree, I'll do cos of 30 degree is over here, root 3 over 2. Okay, so if you remember the table, it's much more easier. See, if I say this is 30, this is 60, this is 90, I can just take it as, you know, 1 root 2 or 1 2 and root 3. Okay, so cos 30 is going to be adjacent over hypotenuse. So this is the adjacent and this is the hypotenuse for cos 30. So it's root 3 over 2. See, this is what I am getting. So instead of sitting and memorizing this, it's easy if you remember this table, this triangle alone. Okay, anyways, you can just learn it however you wish, but this thing is must. You have to remember this. Okay, so write all these in your classwork and then learn it by heart. Okay, so that's the homework for you today. I'm not giving you any exercises. Okay, all right then, see you in the next video. See you in the next session with a new video. Allah Hafiz. Thank you.